Daisy chaining fluorescent fixtures is generally not considered a safe or code-compliant practice, and it is discouraged for several reasons. Firstly, electrical safety is a concern. Daisy chaining increases the current draw on the circuit, which can overload the wiring and create a fire hazard. Secondly, voltage drop is a potential issue. Daisy chaining can lead to a drop in voltage, reducing the light output and potentially causing the fixtures to malfunction. Thirdly, maintenance and troubleshooting become more complex. Troubleshooting daisy chain fixtures can be more difficult and time-consuming, as it requires accessing each fixture in the chain. Fourthly, ground fault protection can be compromised. Daisy chaining can reduce the effectiveness of ground fault protection devices, increasing the risk of electrical shock. The legality of daisy chaining fluorescent fixtures varies depending on local building codes and electrical standards. In many jurisdictions, it is prohibited or requires special approval. Instead of daisy chaining, consider the following alternatives. Firstly, install separate branch circuits to power groups of fixtures, ensuring adequate current capacity and voltage regulation. Secondly, use junction boxes to connect multiple fixtures to a single power source, providing a more secure and accessible point for maintenance. Thirdly, consider using multi-wire branch circuits, known as NWBCs, to run multiple circuits within the same conduit, allowing for more efficient use of space. If you must daisy chain fixtures, ensure that it is done safely and in accordance with local codes. Keep the following precautions in mind. Firstly, use a dedicated circuit with sufficient capacity to support the load of all daisy chain fixtures. Secondly, make sure all connections are tight and secure, using appropriate wire nuts and electrical tape. Thirdly, monitor the voltage at the end of the daisy chained fixtures to ensure it is within acceptable limits. Fourthly, limit the number of fixtures daisy chained on a single circuit to reduce the risk of voltage drop and electrical overload. Have a qualified electrician inspect the daisy chained fixtures to ensure they meet safety standards. Considering electrical safety, it's important to understand the potential hazards associated with overloading circuits. Overloading can cause the wires to overheat, potentially melting the insulation and leading to short circuits or fires. When designing electrical systems, engineers and electricians carefully calculate the current carrying capacity of each circuit to ensure it can handle the expected load. The National Electrical Code, or NEC, provides guidelines and standards for safe electrical installations, including requirements for overcurrent protection devices like circuit breakers and fuses. Voltage drop is another critical factor in electrical system design. As electricity flows through wires, it encounters resistance, which causes a drop in voltage along the length of the circuit. Excessive voltage drop can lead to reduced performance of electrical equipment, such as lights dimming or motors running inefficiently. To minimize voltage drop, it's important to use appropriately sized wires and keep circuit lengths as short as possible. Ground fault protection is designed to protect people from electrical shock by quickly interrupting the circuit when a ground fault occurs. A ground fault happens when electricity unintentionally flows to ground through a person or conductive object. Ground fault circuit interrupters, known as GFCIs, are commonly used in areas where there is a high risk of electrical shock, such as bathrooms and kitchens. These devices constantly monitor the current flowing in the circuit and quickly trip if they detect an imbalance, indicating a ground fault. Understanding local building codes and electrical standards is essential for ensuring compliance and safety. These codes and standards provide detailed requirements for electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. It's important to consult with a qualified electrician or electrical engineer to ensure that your electrical system meets all applicable requirements. When installing separate branch circuits, it's important to calculate the load on each circuit to ensure that it does not exceed the circuit's capacity. The NEC provides guidelines for calculating branch circuit loads, taking into account the type of load, its wattage, and any applicable demand factors. Using junction boxes provides a safe and convenient way to connect multiple fixtures to a single power source. Junction boxes should be properly sized to accommodate the number of wires and connections, and they should be securely mounted to prevent them from being damaged or dislodged. Multi-wire branch circuits, or MWBCs, can be an efficient way to run multiple circuits within the same conduit. MWBCs use a shared neutral conductor, which can reduce the amount of wiring required and save space. However, it's important to properly balance the loads on each circuit in an MWBC to avoid overloading the neutral conductor. When daisy chaining fixtures, it's important to use a dedicated circuit with sufficient ampacity to support the load of all the fixtures. The ampacity of the circuit should be determined based on the total wattage of the fixtures and any applicable dating factors. Making sure all connections are tight and secure is crucial for preventing loose connections, which can cause overheating, arcing, and even fires. Wire nuts should be properly sized for the number and size of wires being connected, and they should be twisted tightly to ensure a secure connection. The electrical tape should be used to insulate the connections and prevent them from coming into contact with other conductive surfaces. Monitoring the voltage at the end of the daisy-chained fixtures can help to identify voltage drop problems. The voltage should be measured under load to accurately assess the voltage drop. If the voltage is too low, it may be necessary to increase the wire size or reduce the number of fixtures and the circuit. Limiting the number of fixtures daisy-chained on a single circuit can help to reduce the risk of voltage drop and electrical overload. The number of fixtures that can be safely daisy-chained will depend on the size of the wire, the length of the circuit, and the wattage of the fixtures. Having a qualified electrician inspect the daisy-chained fixtures can help to ensure that they meet safety standards and are properly installed. An electrician can identify potential hazards and recommend corrective actions to improve the safety and reliability of the electrical system. In summary, daisy chaining fluorescent fixtures is generally not recommended due to safety and code compliance concerns. Alternatives such as separate branch circuits, junction boxes, and multi-wire branch circuits should be considered. If daisy chaining is necessary, it's important to follow safety precautions and have the installation inspected by a qualified electrician. Let's further elaborate on the technical aspects of electrical safety and code compliance related to daisy chaining fluorescent fixtures. When discussing electrical safety, it's crucial to understand the concept of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that can cause overheating and fires. These devices are rated in amps, and they will trip or blow when the current exceeds their rating. When daisy chaining fluorescent fixtures, the total current draw of all the fixtures must be considered when selecting the appropriate size circuit breaker or fuse. The NEC provides detailed guidelines for determining the overcurrent protection requirements for different types of circuits and loads. Another important aspect of electrical safety is grounding and bonding. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to quickly trip and de-energize the circuit. Bonding connects all metal parts of the electrical system together to create an equipotential plane, which minimizes the risk of electrical shock. When daisy chaining fluorescent fixtures, it's important to ensure that all the fixtures are properly grounded and bonded to the electrical system. In addition to overcurrent protection and grounding, surge protection is also an important consideration for electrical safety. Surges are transient overvoltages that can damage or destroy electrical equipment. Surge protective devices, known as SPD, are designed to protect electrical systems from surges by diverting the excess voltage to ground. When daisy chaining fluorescent fixtures, it's recommended to install SPD to protect the fixtures from surges. When discussing code compliance, it's important to understand the role of the NEC. The NEC is a widely adopted set of standards for safe electrical installations. It provides detailed requirements for wiring methods, overcurrent protection, grounding, bonding, and other aspects of electrical safety. Local jurisdictions may adopt the NEC as is, or they may modify it to suit their specific needs. It's important to consult with the local electrical inspector to determine the applicable code requirements in your area. In addition to the NEC, other standards and regulations may apply to electrical installations, such as those promulgated by the Occupational Safety and Health Administration, known as OSHA. OSHA sets standards for workplace safety, including electrical safety. Employers are required to comply with OSHA standards to protect their employees from electrical hazards. When designing and installing electrical systems, it's important to consider energy efficiency. Energy-efficient lighting technologies, such as LED lighting, can significantly reduce energy consumption and save money on electricity bills. The NEC includes provisions for energy-efficient lighting, such as requirements for lighting controls and occupancy sensors. When daisy-chaining fluorescent fixtures, it's important to select energy-efficient fixtures and controls to minimize energy consumption. Furthermore, regarding the specific alternatives to daisy-chaining, implementing multiple branch circuits offers a significant advantage in terms of load distribution and safety. By dividing the lighting load across several circuits, you reduce the risk of overloading any single circuit. This approach also enhances the system's resilience. If one circuit experiences a fault, only the fixtures connected to that circuit will be affected, while the rest of the lighting system continues to operate normally. This is particularly important in critical applications where uninterrupted lighting is essential. When designing multiple branch circuits, it's crucial to calculate the load on each circuit accurately. This calculation should take into account the wattage of each fixture, as well as any other loads that may be connected to the circuit. The NEC provides detailed guidelines for calculating branch circuit loads. Using junction boxes offers a safe and organized way to connect multiple fixtures to a single power source. Junction boxes provide a protected enclosure for electrical connections, reducing the risk of accidental contact and electrical shock. They also make it easier to access and maintain the connections. When selecting junction boxes, it's important to choose the right size and type for the application. The junction box should be large enough to accommodate all the wires and connections, and it should be made of a durable material that can withstand the environment in which it will be installed. Multi-wire branch circuits, or MWBCs, are an efficient way to run multiple circuits within the same conduit. MWBCs use a shared neutral conductor, which can reduce the amount of wiring required and save space. However, it's important to properly balance the loads on each circuit in an MWBC to avoid overloading the neutral conductor. An unbalanced MWBC can cause excessive current to flow in the neutral conductor, which can lead to overheating and fires. To avoid this problem, the loads on each circuit in an MWBC should be as evenly distributed as possible. When selecting wire for electrical installations, it's important to choose the right size and type for the application. The wire size should be based on the ampacity of the circuit, which is the amount of current the wire can safely carry. The wire type should be based on the environment in which it will be installed. For example, THHN wire is commonly used for general-purpose wiring in dry locations, while THWN wire is used for wiring in wet locations. The NEC provides detailed guidelines for selecting wire size and type. When making electrical connections, it's important to use the proper techniques and materials. Wire nuts are commonly used to connect wires together. The wire nuts should be properly sized for the number and size of wires being connected, and they should be twisted tightly to ensure a secure connection. Electrical tape should be used to insulate the connections and prevent them from coming into contact with other conductive surfaces. When working with electricity, it's important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Finally, remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before designing or installing any electrical system. These professionals can help you ensure that your electrical system is safe, code compliant, and energy efficient. In conclusion, while daisy-chaining fluorescent fixtures might seem like a quick and easy solution, it often poses significant risks to electrical safety and code compliance. By understanding these risks and exploring safer alternatives, it is possible to create a reliable and safe electrical system for lighting needs.